Now let's take a look at the this particular problem. This is a helix. The projection on xy plane is a circle with radius 2 and arises from the plane when t is begins from 0. So let's find the arc length as t. According to the formula that we just introduced, it's going to be from starting point is 0, right? T is greater than 0. So I'm going to say from 0 to say t. Now here we need to find the derivative of each component. The first one is so derivative of 2 cosine is going to be sine. So I'm going to use 2 times negative sine. Instead of using the t is fine, but sometimes you might want to use, just think about this as u, right? So think about this, r of u equals 2 cosine u, 2 sine u, 4 times u. For u greater than or equal to 0, they're the same thing. I just don't want you to get confused by the variable here on the upper limit, and this is the variable of integration. So that's why I probably better to change this to u. So that's what I'm doing actually. So sine u, right? And then square plus derivative of the second component, which is 2 cosine u, and then square plus derivative of 4t, which is 4, and then 4 square du. Now this is sine u squared, this is cosine u squared, they add to 1, so we are left with actually just 2 here, right? This is 16 here, so we have 0 to t, square root of 2 squared, which is 4, 4 plus 16 is 20 du, which means, say, 2 square root of 5, if you simplify square root of 20, and then antiderivative, this is constant, so basically just t minus 0, which is 2 square root of 5t, right? So basically, in short, we already found s is equal to 2 square root of 5t. Now let's reparameterize the helix in terms of arc length. Now from what we just find, we do know t equals s divided by 2 square root of 5, right? So we are solving, this is what we meant here. We are so we may solve t as a function of s. Do you see that now? T is a function of s. So once we do that, we can now look at the original function. So r of t should become r of s. And let me write this guy. So r of t is the r of s over 2 square root of 5, right? Because t is s divided by square root of 5, 2 square root of 5. And this is, originally it was 2 cosine t, so it is 2 cosine of s over 2 square root of 5. And then 2 sine t means 2 sine s over 2 square root of 5. And then 4t is 4 times s over 2 square root of 5. And of course, there's a little cancellation you can do, but this is the idea. If I cancel the 2 and 4, we're left with 2. So, and then if we factor out the 2 from here, then we have 2 cosine s over 2 square root of 5, sine s over 2 square root of 5, and 2s, just s over square root of 5. Now, so just a quick review here. We kind of want to summarize the steps needed to reparameterize the function in terms of t to function in terms of x, in terms of s. So step number 1, you want to find your arc length function S of t, right? Step number 2, you solve for t in terms of s. And step 3, you do the substitution. In this case, s will be in this case, your t is a function of s, right? Just like what you see here, t is a function of s. And then you want to plug the t of s into your original function rt to get a function that is parameterized in terms of s, to get rs. So this pretty much is the whole process to reparameterize function in terms of arc length.